Okay, the one thing I like about number 7 is they give me a picture and the relationship. All right, so what I'm going to do is answer the first question. What's dy dx? Looks relatively simple to do. What do you get? 4y dy dx equals 3x squared minus 3. Well, that's easy. So dy dx is going to be 3x squared minus 3 over 4y. So I want to see if I got that right. This is, part A. Was able to get that. They put down y prime. They understand that y prime means dy dx. Do I get the top correct? 3x squared minus 3, 4y. Then they go on to say for what values is that derivative equal to 0. Well, before I say anything, I want to point out a 0 derivative would indicate we're getting horizontal tangents. So what I'm looking at over here, I'm definitely looking at 2 points, by the way. So I'm going to say for what values of x, well, let's take a look at that. Would the derivative equal to 0? So when does dy dx equal 0? That's a question. Well, it equals 0 when the top is equal to 0, provided the bottom is not simultaneously 0. So let's write that down. 3x squared minus 3 equals 0. I would divide both sides by 3. You get x squared. Let's see. I'm dividing by 3. Right? Minus 1 equals 0. So x would equal, let's see, plus or minus 1. All right. So let's take a look at that and see what's going on over here. So I'm going to say clearly I know 1's over here. I'm wondering about the minus 1 right now, but I know there's a point over here at minus 1, and I know there's a point over here at minus 1. All right. So someone's going to say, I wonder about the 1. Well, where would 1 be? 1's over the other side, and I want to write that down for you to show you something unusual happens over there. So I know the x is minus 1. Let's find out what happens at 1. So I'll write this one down. When x equals 1, what happens in the relationship? Let's write this down. So what do you get? 2y squared is equal to, well, 1 minus 3 plus 1. So you get y squared is equal to, let's see what that gives you. Well, look at that. That gives you minus 1. Well, that's not possible for a real number system. Why is that? I can't square a real number and get minus 1. So not possible. So I'm going to say for part B, there's only one value of x that produces it, and it's at minus 1. All right? Now, again, we do want to recommend you read through that. It's not on the graph. All right? All right, let's keep going. What's the next thing? Determine the coordinates on the graph at which there is a tangent line that's horizontal. Oh, let's do that. And I think I can do that. And how do I do that? I got to plug it in. All right, there's some symmetry over here. So I take this point here and plug it in. What do you get? 2y squared. That's going to be x cubed. Whoops, what's x cubed? X cubed is going to be minus 1. And then you're going to get plus 3, plus 1. So what do I get? I get 2y squared is equal to 3. Y squared is going to be 3 over 2. Y is going to be equal to plus or minus the root of 3 over 2. So I know what these points are now. This point over here is root 3 over 2. This point over here is minus root 3 over 2. Again, let's look at the key, see if we got that. And I noticed I did something strange with it. Let me write that down for you. So I wrote down 3 over 2. What they did was they rationalized the bottom by multiplying the top and the bottom by 2. So this would be the same thing as 6 over 4, which means the square root of 6 over 2. So we're getting the same results. All right, I just wrote down the root of 3 over 2, which is fine, by the way. Thank you.